week 17, lesson 6. Okay, so for the past couple of lessons, you've been learning how to find the derivative, all right? And I haven't really explained why you have needed to find the derivative, okay? So what the derivative is, it's the slope of the function at a given point, okay? Which may seem kind of weird. So let me see if I can try to make this a little bit clearer. Okay, so if you're looking at this example, number 1, I've given you a parabola. Okay, in fact, let's graph this parabola. I know it's going to ask you to do that down here, but let's just do that now. Okay, so if I plot my vertex and some more points, it should look like this. Now, if you think about this, depending on where I draw the tangent line, right, the slope is different, right? I could draw the tangent line here. Right, and that would have a positive slope. Or I could draw the tangent line here, and then that would have a negative slope, right? Or I could draw the tangent line here, and then I would have a slope of 0. So that's what the derivative sort of helps you find, is the slope of the tangent line at a particular point. All right, so let's go through this really, really quick. Well, not really, really quick, but let's go through these steps. So for part A, it says find the derivative. You can go ahead and use the shortcuts. So the derivative of that function is 2x. Okay, now it's saying find the slope of the line tangent when at x equals 1. Okay, so if I plug 1, and it even tells you what that means, what is f prime of 1? Okay, so if I do f prime of 1, if I plug 1 into what I just figured out, I get 2. That means at this point, right, at this purple dot, if I draw the tangent line, which I'm going to do, and again, this is a really bad sketch, but the slope should be 2. Okay? Now, it wants me to find the equation of this line at some point, but here where it says find the point of tangency, okay, the point of tangency you get from the original function, not from the derivative. And again, notice here's your hint. It says, what is f of 1? So let's plug 1 into the original function. 1 squared plus 1, and we get 2. Okay, so the point of tangency is 1, 2, right? It's an ordered pair. All right, now for part D, it says find the equation of the line. Okay, to find the equation of a line, you need 2 things. You need a slope, which we figured out in part B, and you need an ordered pair, which we figured out in part C. With a point and a slope, you can come up with the equation. It is y minus y equals m times x minus x. Let me put some subscripts. Okay, so let's plug in what we know. We know a y of 2, we know an m of 2, and we know an x of 1. And if you simplify that, right, distribute, combine like terms, put it into slope-intercept form, you should get y equals 2x. All right, and then we've already done part E. It says to graph the original and the line tangent. Okay, so let me scoot up. We'll do another one. In fact, it's the exact same function. Okay, exactly. Let me graph that really quick. Okay, so let's continue going through our little A through E. So for A, find the derivative. Okay, and again, I gave you a hint. It's the exact same as the first one. Now here, for B, find the slope of the line tangent at x equals 2. If you want the slope of the line tangent, you need to plug that x value into the derivative. Okay, next, find the point of tangency. Point of tangency you get from the original function. 4 plus 1, so that's 5. So here's my point of tangency. All right, and then it says find the equation of the line. So let me do y minus y is equal to m times x minus x. And if I distribute and simplify, I should get 4x minus 3. And then it says graph the original, which I have already done, and the line tangent. Let's see. Here's my point of tangency. 1, 2, right here in purple. My slope should be 4. 1, 2, 3, 4. 1, 2, 3, 4. And if I use a straight edge, that's what it should look like.